The ingredients used are as follows. 1 clear pop bottle, 3/4 cups of water, baby oil, Alka-Seltzer tablets, and food coloring.
We decided to add the food coloring into the water before we added it all into the bottle. First, pour the water into the empty pop bottle. Then add the entire bottle of oil.
To fill the rest of the pop bottle, we had to use a second bottle of baby oil.
We also added gold glitter to our lava lamp.
Notice how the oil and water layers are separate and the oil layer rests on top of the water. Break up 2 Alka-Seltzer tablets and drop them in and watch the blobs rise and fall. But how does this happen? The oil and water do not mix, and when the Alka-Seltzer tablet is dropped in, it sinks to the bottom where the water is. The tablet has 3 main active ingredients: acetyl salicylic acid, or aspirin, sodium bicarbonate, or baking soda, and citric acid. When the tablet reaches the water, the tablet dissolves so the sodium bicarbonate and the citric acid can react. This reaction produces carbon dioxide gas, making bubbles with the colored water, and they rise to the surface and release the CO2. Once the gas is released, the water cannot mix with the oil, and since water sinks below oil due to density, the water sinks back down to the bottom, and this creates the lava lamp effect occurring in the bottle.
Why the oil and water do not mix was because of the polarity of the molecules. What this means is water is polar and oil is nonpolar. This has to do with the charges of the molecules.
A general rule for chemistry is that like dissolves like, meaning that polar molecules only dissolve in polar solvents, and nonpolar molecules dissolve only in nonpolar solvents.
The molecules from the liquids in the experiment will not attract, and the nonpolar oil will almost repel the polar water molecules, making it hydrophobic.
The oil stays above the water because the oil is lighter than the water, or more specifically, less dense.
The water molecules are more tightly packed due to the hydrogen bonding, which makes the water molecules very attracted to each other. The oil molecules do not exhibit this type of bonding and cannot pack together as tightly.
Because of this, water and oil will always separate with the oil on top of the water, like when oil from oil spills stays on top of the surface of the water. Even when mixed or shaken up, the oil and water will always eventually separate due to their molecular properties. And that
is what makes this experiment possible.